maybe like a
So
personal.
the moral is you shouldn't miss class.
maybe he'll do a personal lecture for you guys.
I mean, I'm available. You can, yeah, you can stop by.
Yeah.
And, I forgot about that. I will post. I'll give you guys the completed notes.
Thanks.
Yeah.
There you go.
Adam
Shouldn't miss class. I told you shouldn't miss class.
also mentioned they're doing like precast panels for a building for Simpkins that's going up in town.
Oh, really? So it might be
He
worth
said
going
they
to see
might
that.
be able to set up a tour
Sure.
for their Bozeman location.
Yeah, and then that hotel downtown that's being built right now. That'd be good to go visit too.
But you said he'd reach out on when they're like delivering those.
All right, so we got. I gotta get organized here.
Popped up on the TV right when you were tackling. I was like, that's not to sit in there looking pretty.
He does look pretty when he's sitting there, though. He does. But he shaved his beard off, or his mustache.
Yeah, what's up with that?
Change it up. Keep you guessing.
Yeah.
Gotta keep you guessing.
All right, so we're talking appreciate. First of all, it went okay. I heard from some of you that it went good with Adam on. I think that we've learned that maybe they're not. You just spill coffee on yourself. No? I heard that they might not be a PCI producer member, but I think we're gonna apply this week hopefully and just make sure that they can actually do it, even though they're not a PCI member or whatever. So so then that way that we could really take off on your exams. Did he talk about like time frame or anything like that? Like when we need to get him designs and when are we looking?
The long story short is basically if we're doing mixed design, if we do our own mixed designs by about Monday, next Wednesday maybe,
Okay.
and then they're gonna cast those cylinders, and then like 28 days later have the beam designs.
Okay.
Before.
Yeah. I mean, do you guys want to do your own mixed designs or just use their mixed designs? Right?
The rules are a little weird because it says you have to have like 1 to 2 pages explaining your mixed design. Does that mean we can use theirs?
Absolutely, and then we'll just explain what they did. Right? I mean, that may be the easiest thing, is just use what they're used to using and then just crank it out. Because like we don't know like what our slumps would be. If you guys remember in Structures 2, like what a pain in the ass that was. Like you estimate what the slump is, but what you actually get's different. And then like what all the strengths are and stuff. We just use theirs then.
They did say they'd be happy if we sent them a mixed design to do all the tests, get us all the data.
And if you wanted to do that, it's up to you guys. But anyway, so keep that in mind as you progress through the stuff, and then we'll try to get an approval that we can actually do it. I do want to show this. Oh, so I stay at this lookout, and I'm actually gonna stay at it tonight too. This is a Garnet Mountain Lookout. It is open tomorrow night if anybody wants to use it. I know you guys have class at 8 in the morning, but I'm sure if you told Tim and I are going up to it tonight with a couple friends. I'm sure if you told Tim what you were doing, he would record lecture or not. He would say he would record lecture, but he actually wouldn't record lecture. But look at some of these shots that we got. It's really cool. I rent it every fall, and we go for there. Also, this deal.
Oh, Jesus.
Damn right, I was watching it.
Whoa.
Fucking deal right there. So what's that again? The sound. Look at that shit, Neil, huh? Look at it, he's all pumped up. How was your elbow? Good. A little replay of it, dude. Boom! It's fucking form tackle, man.
That's a good hit.
Isn't it?
That's like a
Yeah.
I said when I watched it, I was like,
Yeah.
tackles make me angry. That's a really good hit.
That's a good hit. We'll just watch that over and over. Film. How did film go? Film was good, right? Right? Oh, you haven't had it yet. Yeah, right. They're going to be talking about that one. He's pumped. Boom, dude. Fuck, you see his head shake and shit, dude? That's a good deal. Good job. And also, those motherfuckers called you for a holding penalty that wasn't you.
Oh.
You didn't touch anybody. I watched that. I kept going back and forth. You're just standing out in the open. Not doing shit.
Sitting
Yeah.
there looking pretty.
I think they meant to call it on 18, but they called it on 19 because they brought when you did that tackle. They're like, "Oh, good, welcome back, Neil." Did you see this clip before?
A little bit here and there.
Yeah, this just says like, "Welcome back, Neil," and then they're like, or Daly, and then they're like, "You know, he did have that holding penalty early on the." So
Not even the same skin color.
that's you got blamed for it, Neil. But anyways,
The Grizz almost lost to those guys.
what's that?
The Grizz almost lost.
I know.
They almost lost to Cal Poly.
Yeah.
Yeah, they did. Yeah.
It was
Frauds
God.
of the year.
Hopefully.
7-9 going into the
I
fourth.
freaking hope. I hope so. Okay, so then what's coming up? We have one topic left, right? We have one topic left, and the topic is. So, is anybody interested in the lookout? I know it's hard, but like,
Do you have to pay for it?
no, I got it. Yeah, for tomorrow night.
Why aren't you using it?
Cause I'm using it tonight, and I use it on Friday night, and then it's a pain in the ass getting up there. So it's not like I'm riding a 4-wheeler. I ride a 4-wheeler, and I did that with my family. We all rode 4-wheelers up there. You'd have to hike in, but because it's a bar 4-wheeler. I have 2 old ones; they wouldn't make it. But because it snowed up there, and so I think Bryce used it on Saturday night, and he went up there in the rain, and then like it snowed like 6 inches overnight, and then he came back down. But you take some time off, Neil. You gotta go up there, practice off, and yeah. Think about it, because it's really cool. It's rented out every night of the year. I booked it 6 months ago, right on the 6 months to the date, right at the time that it opened, and got it for like 5 nights or something like that. And so that's all. You're thinking about it.
Thinking about
Yeah.
it, but also Tim's not going to record lecture.
No, but he'll. I'm sure he wouldn't count it against you, but then you'd be up for you
He
to.
loves catching people. He went through 3 names this morning trying to get someone.
He just kept going.
He didn't get anybody.
It didn't work.
Even though only half the class was there, I picked 3 names that were all there.
He's mad. He's probably mad that happened. Right? I bet he'd understand. It's cool. And then, so you have to hike in. It's about 4 miles in with 3,000 feet of vertical. It's the lookout that's like if you're driving up to Big Sky and then like right by Storm Castle. It's right across from Storm Castle. You look up there and there's like a little lookout tower that's sitting right there. You know, think about it. Think about it. It's hard to get in there. Okay, so we're talking about pre-stress losses. So we have pre-stress losses that we're going to finish up that today. And it's a pretty prescriptive method for calculating pre-stress losses. Then we're going to do composite construction, which actually works out really well for those of you in eGen 415. Who's in eGen 415? Because it's going to be a method of composite sections or whatever, right? That we're going to method of transform sections.
Kristen said she convinced you to teach it this way.
That's bullshit. No, that's bullshit. I've been talking. Did she say that?
Yeah.
No, I've been teaching it this way forever, and then she used to teach it a different way. I was like, and then I was like, you should keep teaching it that other way because it makes me look like a better teacher because you teach it a very convoluted way versus the way that we do it. It's gonna be straightforward, and that's it. So we're gonna cover that, and that's it for pre-stressed, precast type concrete stuff, right, for the notes. So we should be done with that the rest of this week. Next week, Monday, Kyle is going to start talking, not this Kyle, but a different Kyle. He's going to come in, or he's not going to come in, but he's going to do it remotely. He's going to lecture to us on post-tension floor design. And so he gets the floor for 2 weeks, basically. So for 6 lectures, he's going to talk to you about doing post-tension floor design. We'll probably have one more homework in there associated with that. We have one more homework that I'm going to assign today. So we have one more homework assigned today, and then one post-tension floor design, and then we're going to do an exam. Okay? And then that'll be sometime around Halloween-ish, around that vicinity is when we'll do our exam. And it'll be on this pre-stressed and post-tension floor design, okay? And then we'll switch over to bridges for about 2 weeks, right? Whatever it is, because there's Thanksgiving coming up, and so it'll be, and then the bridges is just gonna be like a survey course of just like, look, this is the code book, and this is what would be different if you went to do this, and that's it. And then we'll have an exam associated with that. And then somewhere in there, we may be breaking beams. Or will it be next semester? Yeah, that's fine.
It would
Yeah.
probably be like in the middle of December.
Okay.
at the-
So
Earliest.
break or next.
Okay. Yeah.
Didn't
Or
we
next
decide we want to break them at 28 days too?
Yeah,
think
they
so,
would-
but I think we also-
28 days. series.
Okay.
wanted to get into the lab before all of ASC and structures too.
Oh,
and the
sure.
CT concrete class
Sure.
are-
Yeah, all that stuff's going down. So that's where we're headed. I mean, it's crazy to think that we are halfway through the semester already. Or are we past halfway?
I think last week. I think with the
Don't hurt his elbow, dude.
Fire over here.
Yeah.
I got you. I got you, Neil.
Okay. So that's where we're headed. So, anyways, it's crazy to me that we're this far away. Okay, or this far into the semester. So this is just to say, we were just talking about pre-stress losses, right? The biggest issue with the pre-stress losses is your serviceability stuff, right? If you overestimate or underestimate pre-stress losses, we discussed the pros and cons, or not the pros and cons, but just what happens if you underestimate pre-stress losses. You lose more stress than expected. FPE is less than expected. It might crack under service loads, right? Your cambers will be off, right? But it most likely will not kill people. Right, and it's not really a safety issue. It will affect your shear capacity because if you remember, there was all sorts of pre-stressing terms in your shear calculation, so it will affect that, but it won't affect your flexural capacity too much. Okay, if you overestimate the losses, that's what we're going to talk about next year. This is for your homework. You don't need that here. So let's talk about what happens if you overestimate losses. All right, we lose less than expected. FPE, PE is bigger than anticipated. Which you might think that that's not that big of a deal, right? If you have your pre-stressing force is bigger than it's anticipated, but it is going to mess with deflections and cambers. Right? You're not going to get like premature cracking with this, but your deflections may be affected significantly. Okay. Shear will be affected, but flexural not so much. Okay. I don't know if you have this note or not. I don't think you do. Right? This came out of ACI directly. It says, the best effort to calculate pre-stress losses is only an estimate, and therefore the licensed design professional should consider the consequences of actual losses being higher or lower than the estimated value. Estimation of pre-stress losses is an important factor for evaluating the serviceability of all types of pre-stress members and calculation of flexural strength members with unbonded tendons. The estimation of pre-stress losses, however, is not a significant factor in determination of flexural strength of bonded pre-stress members. So bonded pre-stress members, it's not going to affect it that much. Okay? When computing shear strength of the pre-stress members with little or no transverse reinforcement, a conservative estimate of the effective pre-stress forces are warranted. So ACI tells you it is important. Right? This was, you don't have to study this too much, but I was just trying to show what happens if you go this direction, you underestimate losses, in that direction you overestimate losses. And you can see that, even if I go down to like this has my flexural capacity. It's a flexural capacity. It's just showing that the flexural capacity is not affected by much. Even if I underestimate my losses by like 0.75, that's what that value is, my flexural strength is only off by 7%. And same thing on this side. If I overestimate my losses or underestimate my losses, even by 40%, my flexural capacity is only affected by 2%. So it doesn't really affect it that much. There were some students that questioned it a few years ago, and I was like, actually. So I went through and I made this little plot to say, look, it doesn't actually affect it that much. Okay? But it will affect it bonded or unbonded pre-stressing a little bit more. Okay, so how do we predict these capacities, right? So let's look and see what ACI says. So this is ACI 318.14. I looked at 19, it's not changed, right? So pre-stress losses. Pre-stress losses shall be considered in the calculation of effective tensile stress in the pre-stress reinforcement FSE and shall include A through F, right? Pre-stress reinforcement seating and transfer, right? That's the seating losses, elastic shortening, creep of concrete, shrinkage of concrete, relaxation of reinforcement, and friction losses due to intended and unintended curvature. So this is unintended curvature would be your wobble stresses that we talked about. That's it. ACI says you should do it. You should come up with a method that does these things, right? But it doesn't tell you what that method is, okay? But that's the same deal. It's like, it's important, you need to do it, go do it, and then they give you some references. We're gonna use out of the PCI, and what PCI uses is this Zia et al., 1979. Very current method for predicting losses from 1979, and so that's what we're gonna use. But it's similar, like I said, they point you in the direction that you need to do. Okay. There's another little comment here, right? Actual losses greater or smaller than the calculated values have little effect on the design strength of the member, but affects the service load, behavior, deflection, the camber. And it says that service load overestimation, right? At service loads, overestimation of pre-stress losses can be almost as detrimental of underestimating the losses, right? Because you can get excessive camber and horizontal movement. So it tells you to be very careful about it, okay? But they don't actually give us a reference. They don't give us a method, but then we're going to use this PCI method below. Right? They have a little bit more in the commentary that they talk about. Okay, so then there's this PCI chapter 5.7. So here's chapter 5.7 in the PCI design manual, and then loss of pre-stressing. Okay, and talks a little narrative. It'd probably be worth reading through this thing. Sources of pre-stress losses, right? Elastic shortening, shrinkage of concrete, creep of concrete, and then how do we actually estimate those pre-stress losses, right? And so here's the equation. So your next homework is going to do this. You're going to estimate pre-stress losses. So my total losses is going to be this ES, which is elastic shortening, plus the CR, which is creep, plus this SH, which is shrinkage, and RE, which is relaxation. And so then basically, it's very prescriptive. You then go through and it calculates, oh, here's what ES is that we use, and they tell you what all the variables are. Then we go down and we calculate CR, and CR is used with this empirical equation, and it tells you what all the components are going forward. And then they give you, and then they keep going, and they go through and they tell you what RE is, and so forth. Right? And so it's very prescriptive. So when you do that, you'll just go through and follow that step by step. I think it's all pretty self-explanatory, very, very prescriptive. And then also they provide an example. So here's an example of them applying it to a certain structure, and you can calculate the pre-stress losses. One thing noting, we talked about this at the beginning of the semester, right? This is the range of pre-stress losses that we're going to get. The range of pre-stress losses is from 25,000 to 50,000 PSI. So there's a lot of loss that happens, right? That's why we're using 270 KSI steel, so that when we lose 25 to 50 KSI in the pre-stress losses, we still have some effective pre-stressing forces. Otherwise, if you use conventional steel with a yield stress of 50 KSI, you could stress it all the way up to yield and then transfer it over, and then just have nothing left, right? There'd be nothing left after all the pre-stress losses. Okay, so like I said, you'll do that. The other thing, AASHTO also has a method. Okay, we'll look at AASHTO a little bit, obviously, when we talk about bridges, but they have a method, and theirs is very prescriptive. They do say, oh, it's important. It's structured very similar to the PCI, where you just have the total pre-stress losses has it's elastic shortening plus the long-term pre-stress losses, and they give you an equation for it. It's very, very procedural and prescriptive method for calculating pre-stress losses. So they have one. If you go into bridge design, you'll calculate it this way. Okay. Also, ACI 432 R6. This is committee 432. They have a full committee on estimating pre-stress losses, a full document. So there's a document, ACI 432, and it has methods for predicting those. And it basically uses the references in ACI 318. ACI 318 says, here's some references. This does a little more deep diving into those references and then gives you that. So if you end up find yourself calculating pre-stress losses, right, that you could use this method as well. Okay. The other thing, I don't have it in the notes, but right, also these are often supplied by manufacturers, right? I guess maybe these is maybe more clear. Pre-stress losses They're provided by manufacturers, right? Those plants know how much pre-stress losses they're going to get, and they'll tell you, right? So that's something that, did you guys discuss that at all with Adam on a little bit? Maybe not, because they should have an estimate on what those pre-stress losses. I think maybe you guys may need to calculate them as part of your designs. But then also they know. So it might be worth following up with them later and just say like, what typical pre-stress losses do you get, or what equations do you use? Because they know, because they've been, they've been making their members for a long time, and they know what kind of pre-stress losses they get. When we talk with Kyle next week, he'll explain to us, like when you do post-tension floor design, what you as a designer give the fabricator or the people that are assembling and stuff, you give them the effective pre-stressing forces that you need for your designs and what it is that you put into your equations. And then on the other end, they go through and they estimate like, how many tendons they need and what they need to stress them to and what their losses are going to be, so that when they deliver it to, when they actually deliver the product and post tension in place, you're getting the effective pre-stressing forces that we as engineers told them that they needed. So that's how they end up doing post tension. You just say, this is what I need for my design, this is what I use in my calculations, and it's up to them to estimate the losses and the pre-stressing, what stresses they go to, and how many strands they use. They do all that, and he'll explain that more later. But that's just something to know. I mean, not to mention, right, we mentioned before, when you order up one of these pre-stressed beams, they're kind of come pre-engineered. Like the people at the place actually do the estimations and they design them, and then we just check their designs that they're doing it the way they're supposed to do, like these pre-stressed members. Did Adam say anything about, do they have like an engineer on staff? Yeah. They do. Was he here? Yeah. Did they come here just for us? Did they drive from Missoula just for us, or were they in the region for something?
I don't think so, because they also brought one of their architects down.
Okay, so I wonder if they're here for something else. And then
The architect is out of Spokane. So I was wondering.
Yeah.
Pull over though.
he was?
Yeah.
Good.
Who's the?
Also, the engineer is Adam's dad.
Yeah.
Oh, it is?
Yeah.
The engineer is Adam's dad? Oh, interesting.
You wouldn't hear them before completing.
Oh, he did. That's pretty cool. They're excited. Neil, did you tell him you're on the football team?
No.
What the fuck, man? I would have told him. I would have told him. Were they Grizz fans?
No.
No, they were.
all.
Oh, they're all Cat.
Yeah.
Thank God. All right. Neil would have had to kick their asses. Get out of here. Okay. All right. That's it. That's it for pre-stress losses, right? So there's all these different methods. We're just going to use the PCI method. And again, you'll see the homework when I do assign it. It basically is I grab one of the sections out of PCI design manual and just say, verify that it can carry this load. And so that means you go in and check to make sure that it works for the service conditions, that tension at the bottom, or tension at the top, compression on the bottom under initial conditions, vice versa for under service conditions. Make sure it can carry the ultimate moments, make sure it can carry the ultimate shears, and then estimate the pre-stress losses and then estimate cambers. And then you can actually compare your estimate of camber versus what's in the because they have estimates of camber in that table. And so it sounds like, but you guys have a program that does elastic amount, right? We have that kind of proves that, either the ones where the tendon profiles where you can put the member, or if your allowable stresses are above or below the limits, then you have the ultimate moment capacity. You have a spreadsheet that did that, or code that does that. And then same thing with shear capacities. And you can see that actually, I think it doesn't quite work. I think that it's really close. It's really close in some areas, but according to our calculations, I think it might fail in a couple of spots. And they put some stuff in there that's like, oh, it might fail in certain spots, so we're going to put in extra reinforcement in these areas and stuff like that. So that's what you're going to do. It does take a while, just because you got to deal with those freaking tables, right? Of like what all the variables are and stuff like that. But again, it shouldn't be too bad. Okay, so composite construction is the last topic we have.
So this is where we get Kirsten's method.
This is where we get to Kirsten's method. So ours is going to be a little bit more difficult, though. And so composite construction, there's all sorts of composite construction. Like reinforced concrete in general is composite construction. You got two different materials that you're including together, steel and concrete. So just in that sense, that's composite construction. You also have composites. You've heard of composites, right? That's like plastics and fibers and stuff like that, those are considered composites. In this consideration, in pre-stressed concrete, when they talk about composite construction, we're talking about pre-stressed beams with composite concrete deck. Okay. That's what we're talking about, composite construction. So you come in and you put down your pre-stressed beams, and then you cast a deck on top of that. And that deck will act compositely with the pre-stressed members. And you can see how this is going to get complicated because your pre-stressed beams are made of a higher strength concrete with a higher elastic modulus. So you have like a 10 KSI pre-stressed concrete beam, and then you put on top of it a 4 KSI concrete deck, right? So there's two different materials there. But also, the pre-stressed beam is pre-stressed, and so it's already in a stress state. It has compression, it has pre-compression and all this stuff going on. But then the deck doesn't have that, right? So the deck is just going to be starting from scratch when it starts out. And so then there's this. We have the same load stages: initial load stage, and then service load stage. But then also on top of that, we also now have a deck on top of it that then they start acting compositely afterwards. And so what happens with the pre-stressed beam at the beginning stays the same, like the initial pre-stressing and the transfer, like it doesn't have the deck isn't included at all. Then you go out and you put your beam down, your beams down, and then you cast the concrete on top of that. And so then the beams have to then carry the concrete to begin with. And then once it hardens though, then it'll be ready to be loaded. And at that point, from there on, it's going to be acting compositely. So then when you apply the service loads on that, now the deck is getting included in the flexural response. And so then we have to, you'll see, we're going to get down to these guys, right? Where sometimes you're going to be using the pre-stressed beam alone. Sometimes you're going to have the composite members, right? Stanton has it in his notes, but his is garbage. The problem with his is he makes 1,000 mistakes in his. So we're not going to. There's all sorts of mistakes. And so then you're trying to learn it, but his is even more complicated because he's also using those kerns throughout and stuff, and it's just confusing. So we're going to have our own things. But that's why this ends up being complicated, is because we have to do methods of transform sections partway through, but only certain parts have that, and other parts don't have it and stuff. So that's why it's going to take a couple days to go through it. Okay. All right. Pros and cons of this type of construction. Pros. Reduced construction time. A, B. Right. Accelerated bridge construction. That's one of the things, right? When you don't have to like cast a beam in place, you just have a pre-stressed member that you just come in and just plop it into place and it's ready to go, and then you just form up the deck on top. Then you could speed up the process, right? And that's a big word and a big concept in bridge design is this idea of ABC. That's what they call it, or accelerated bridge construction. How quickly can you get something in? There's a big range of that. When we did a bridge in outside of Wisdom a couple of years ago, when we used UHPC, that was accelerated bridge construction, 96 hours. They tore out the old bridge and then built a new bridge. And the way they did that was all with precast members. They had all these precast double T's that they kind of just came in and put into place. They tore out the old one. They had a bunch of precast caps that they put into place, and then precast like double T's that they put into place. And then we used our UHPC to glue it all together. And so in 96-hour window, they replaced the bridge and had traffic on it again. And then we did it again a couple weeks later. We did that. That's accelerated bridge construction. They also do, a few years ago outside of Livingston, they built the bridge off to the side. And then so there was an existing bridge on I-90. It was they had it sitting there and they just kept using it and stuff. And off to the side, they built the other bridge, the replacement bridge. They assembled it, got it all ready to go. And then when they were ready, they just tore out the old one and then just slid the new one into place, and then it had traffic within like 24 hours or something like that. That was one of our grad students worked on that project. It was pretty cool. That was accelerated construction. But this also fits under that as well, because you just have these precast members that are ready to bear, to have load on them immediately. All right. They do complicate things though. All right, the cast in place deck is wearing surface. So you're not actually driving on your beams, you're actually driving on a deck that's on top. And then at some point, maybe that that wearing surface will get worn down, and you can just take off the top surface and then put on a new wearing surface. Sometimes they put asphalt on top too. We're just gonna do concrete on top, right? Shoring can be eliminated. Right, so if you have a big pre-stressed member, you could, shoring just means like, do you support it in the middle while it's being built, and then you release the load and it transfers it over. If you have big enough pre-stressed members, you don't have to do that. They can just span across. The benefit of that is if there's like traffic underneath the bridge, you don't have to have shoring sticking down there, right? The formwork. Right, 'cause you don't have to have formwork for the beams and stuff. Lots of pros here. Added slab provides continuity. It kind of ties everything together. Oh. Ties everything together. Gavin, are you sick?
Oh, it's cold weather.
I guess it got fucking cold. It was cold this morning, wasn't it?
The wind.
The wind, like, yeah, just walking, the eastern wind just blasting you. It's terrible.
Reminds me of Fairfield.
Oh yeah, makes you feel like home,
Yeah.
right?
Sucks.
Right.
The wind.
Right. My wife doesn't like when my kids say suck, and so we call that the S word.
Suck.
Suck. Somebody says that sucks. They're like, Tyson said the S word. That's the big one. Reduce vibrations, right? Because everything's kind of tight. Like, this is the benefits of having everything tied together. Reduced end rotation. Right, which means smoother rides. If you have a bridge and you have, so I kind of have drawings down below to kind of show it, right? So if you have like two double T's that are sitting next to each other, or even if they're separated out, but even if they're separated next to each other, you could drive on this, right? This is what we did in Wisdom. We didn't put a driving surface on, but this would be looking at the cross section, right? There could be a car on top of this, right? That's driving along the way, but if you imagine putting a slab on there. Let's see if I got this. Right, it goes across the. Oh, you motherfucker! I'm so mad. There we go. Right, it just kind of ties it together. You put this slab on top of it, and just kind of said, like, instead of one carrying the load and the other, now you're going to share it between the two, and they're all kind of tied together. Right. This would be looking in the other direction. Right. This would be not the cross section, but you're just looking at the spans. Like, here's your car. I'm gonna draw my car here. That's pretty good, actually. Oh, motherfucker. A Cybertruck. That's a fucking Cybertruck. There we go. That's good, Luke. It's a Cybertruck. God damn it. I was trying so hard. I was really proud of myself. All right, so there's my Cybertruck driving along, right? And if I need to move it up. I gotta provide for that. That's really funny.
So we're gonna assume it doesn't fall apart before it crosses.
That's right. That's right.
It becomes a dead load when it breaks down.
God damn.
To break down.
We're
Right.
just
Doesn't
testing-
matter, they'll do it
We're just
anyway.
testing heat resistance and all the components, which is fine.
Right.
Really unfortunate because it's been like 12,000 pounds.
Just drive along on there, right? You can see that by end rotations, this is what I'm talking about. Like right, oh, god dang, I missed his wheel. End rotations right here, right? Right. If this thing wasn't composite, right, this guy would bend down like this guy would bend down like this, and so that if you're driving along, you'd get a little, there'd be like a bump in the middle there when you go across that. Versus if you tie them together, you're going to get reduced rotations and make that a little bit more smoother ride along the way, right? And you'd have negative moments going through there and stuff, so you'd have to put in, you'd have to have some, some rebar and stuff in here, tying that together and stuff, because you get tension across that. But that's what I mean by like just smoother rides, but you put this thing on top of it. Okay. All right. I don't know if you had this in here before. This is a joke. I saw this right here. Right? Like when you try to draw, when I try to draw, the car used to draw, I get a car and pulls out. So that's kind of what it looks like when I draw a car. And that's like a real car that looks just like that.
I don't know if you can call that a real car.
Good point.
It's,
Is that a tow camper attached to it?
I'm not sure. I mean, it does look like that. It's what it looks like. There's like a trailer that they like welded together with it.
it looks like they welded a camper to a truck cab.
Right.
Front end on it.
Yeah, that's right. And then piece it together. It was running. It was at a gas station. Okay. Cons. What do you think a con would be? Cost. Right? If you do it this way, it might cost a little bit more. Right? Placing concrete. In general. Right? And then another one is, this is just pre-stressed like bridge elements in general, like why these could be difficult. Transportation. Well, that works through transportation is what I wanted. Of precast members. Right. You do see, like when you're driving down the interstate, right, you look up at all the overpasses you go by and most of the bridges, most of them nowadays are pre-stressed concrete. There's some exceptions, like the bridge that's going over Rouse, when you drive under Rouse and the interstate going across, those are big steel girders. Steel girders, you can get further spans and stuff like that, but we use pre-stressing a lot just because it's super durable. It's concrete, right? Despite what Tim says, right? Concrete doesn't rust, right? And fall apart over time. It does really well. And so it gets used in bridge construction a lot. It gets used a lot more than like trusses. You don't see trusses really going in anymore, right? These big trusses that are going down. It's unfortunate because they look cool. I think they look cool, right? And like they're pretty soon in the next couple of years. I don't know if you guys ever got to Axtell Bridge. That's a big old truss bridge. They're going to replace that with girders. Yeah, I know. But it makes sense, right? It's a one-lane bridge going across, this 100-year-old bridge, or you get 2 lanes of traffic with a pre-stressed member that's going to last for, a couple hundred years, right? So they're unfortunately going to replace it with that. They're not as cool though. Yeah. Transportation of members. I only have a few YouTubes to show you, but here's the transportation of a member. On Mountain Road. Isn't that crazy? tilt your head sideways real quick. Just steer the back end of it around. They have not watched Final Fantasy. Yep. Yeah. I thought the same thing, Sean. I thought the same thing. Tuck and roll. Is he pushing? And then, by the way, look. No, we're going to talk about this in a second. Note all the rebar that's sticking up from there, right? And that's that. We're going to talk about that shortly. So that's basically they're going to cast a deck on top of it. They're going to be spread out, and they're going to cast a deck on top. So, one of the few videos that apply to pre-stressed concrete. Okay, issues and concerns: shored versus unshored. Right, shored, you get smaller sections. Right, there's no need to support full weight of wet concrete. And then no shoring. Get no disruption of traffic. Below bridge. But you end up with bigger sections because you have to support wet concrete. Again, shoring just is, do you support the bridge mid-span or someplace along the way, support it from underneath when you cast the concrete, and then you cast the concrete and then you remove the shoring? Or do you just have the pre-stressed members carry the full wet concrete as it goes across, right? So that's something you have to consider along the way, okay? The different concrete strengths and different stiffnesses. Right, deck is typically conventional concrete, 4 KSI, somewhere in that range, right? Pre-stressed member uses at least 6 KSI. Did Adam say like what they usually get for their 8,500 PSI? Yeah.
After
They try to get to 42 overnight.
42 overnight. That's pretty cool.
Well, they want 35, so they shoot.
Okay.
After
The
law,
last
they
room,
can.
that was like 13,000.
Oh, really? 13 KSI. What's that? After 4 days, it was 13 KSI? Yeah. They.
Why?
What's that?
Why?
Because you can, right? Because you can.
This is why we do our own mix. So we can do that.
I don't want to.
What? Oh, yeah. They're for different stiffnesses. They end up with 2 different stiffnesses, which means that you have to do method of transform section. It's not spelled transformed. Right, so we have to use that. All right, and like I said before, the pre-stressed beam is pre-stressed, the slab is not. And so they're already starting out at different stress states. Okay, so then we'll also, I guess we'll, we got just 2 minutes here, but then we'll leave it for there now, and then we'll do effective width, right? So how much, that one's dealing with how much of the the deck can you use as part of your composite section, right? The shear transfer, and then we'll just dive into this method transform sections, and then give you a procedure for how you calculate it, and then you're on your way. So, cool beads.